Hello everyone, in this video we will be looking at the fine tuning of Mask RCNN using PyTorch. So basically we will be implementing the PyTorch code and we will also be looking at the theory whenever needed. Okay, so we have the code over here, and as you can see we are basically doing some imports. So the most important part here is these two, the FastRCNNPredictor and MaskRCNNPredictor. I'll be explaining to you why we need both of these and what both of these mean in the theory part, but first let me get done with all these smarter codes. So these are the basic images that we are having, images and masks. So as you can see in the data set, wait, I'll just show it to you. Let me open the data part and then the Penn Fudan pedestrian data set. So basically what you have is there are certain images. So as you can see are the PNG images. So there are certain images, one of them you can see on the screen, and then you have associated masks. So for example, let's see the Fudan ped 0001.png. So with this image there will be an associated mask. I'll show you in a second. So obviously you can see the same image and then mask_mask.png. So as you can see in the image, the masks are basically, what you need to do is there is an image and then there are some people in the image. The idea of the problem is to find the masks of the people. So you have to not only find the bounding box which you will get from the FastRCNN, but you're also going to find the segmentation mask which can be used later. Okay, so I'll explain what that is. So this is all the images names. So as you can see, os.lister, and masks are all the or the mask names. Okay, so I am taking the index 0 image and index 0 mask. So as you saw, this was the image. So this is our first image, and the way masks are is, first of all, there, if you take the mask and find the unique numbers, as you can see in this image over here, there are two people. Okay, one person, second person, and then there is a background. So obviously the background is referred to as 0, this first person will be referred to as 1, and this second person will be referred to as 2. So which means that if this is an image, this will be 1 and this will be 2. Okay, so that's why I'll show you this in theory. I have with the slides right now, but I'm just going to make this very clear in the start. I'll be showing you in the slides. So np.unique, numpy unique, if you take the mask, you'll get 0 1 2. 0 is for background, 1 is for the first person, and 2 is for the second person. So let me show you the first one, the mask, wherever the number is 1, which is 1 was for the first person. Okay, if you remember. So you can see the mask over here. Let me go on top. You can see. So we put np.array.mask, np.array of mask double equal to 1, which means give me only the places where this is 1. So this person's segmentation mask is there, and the second person's segmentation mask is here. So as you can see, I have put here 2. Okay, now I'll go to the slides and show you what this means. Okay, so this was the image and this was the first person mask. Okay, and then this one was the second person mask. So for this one, now the idea over here is, as I said, all of the background will be 0. So as you can see, these green zeros. So obviously an image is nothing but your pixel value, zeros, ones, two, and then let's say this is a binary mask. Obviously it's not, but segmentation mask is a binary mask. Okay, so you have 1 for this person. So all the pixels that are over here, okay, will be 1. Now obviously this is half black, half white, this is there, but in reality these pixel boxes will be very small. Okay, so let's say this is 1, this is 1, this is 1, because most of it is falling in 1. This is also 1, this is also 1, this is also 1, but wherever the person is not there, we have 0. Similarly for this person, now you could say, oh, here it could be 2. Yes, but mostly it is empty, that's why I put it 0. Okay, so this is 2 2 2 2, all these are 2, here also 2 and 2, which means that if you can see, if I have to find only 1, then I have to put this 1 as true and rest everything as false. So for example, we will have this person. Okay, so this was the segmentation mask that we had got, and this is how it was it was put in grid, or how the image was saved on the computer. So some of them will be 0, the background, and even the second person which is not there will be 0, and this person will be 1. Similarly for the second person, everything else will be 0 and this person will be 2. So this is what we need to do in the upcoming slides. Okay, so this is what I wanted to show you. So this is the custom data set that we will be using. So these are all the images we saw in the over here, the images. If you remember, these are all the images, and then the masks are also there. So these are all the names. So as you can see over here, the images are here and the masks are here. So for every index idx, so we did it for idx 0 that you saw above. You take the image for every index from over here, you can see images dot idx, okay, and then you also have the mask, and you convert the image into RGB format. Then what you do, you take the you convert it into a numpy array, you convert the mask into the numpy array, and then you find out the unique values. So for example, in this image, how many were there? In this image that we saw, in this image there were 2 people and 1 background, so 3. So you have 0 1 2. So let's say if there were 3 people, then this would be 0 1 2 3. Why? Because there were 3 people and 0 is for background. Okay, so this mask, this np.unique will give us the number of objects, but the number of objects also contains the 0th, which is the background. So number of people is from 1. That is, you could also write whatever number of objects is the length of this array minus 1, because 1 is for background. So number of objects becomes since we are removing the 1 from here, the number of objects is length of obj underscore ids. Okay, and the mask, I'm just initializing it as a 0 mask. Okay, so each mask is of the size mask shape 1 and mask shape 2. And how many masks will be there? Well, the number of objects, number of people. So in this case there were 2 masks. Why? Because there were 2 people. This was the first mask and this was the second mask. Okay, so number of people are number of objects, so number of objects cross mask shape 1, mask shape 0 and mask shape 1. Okay, now what we are trying to do is we are trying to differentiate the mask, which means in the mask all of these were there. Okay, so all of the masks contain 0 1 2, all the information. Okay, but what we need is basically the single person. So in order to do that, we had to do something like np.mask double equal to 1. Same thing we are doing over here. np.mask whatever mask equal to I plus 1. So for the first one, I will be equal to 0. So I plus 1 will be equal to 1. And then for the second one, I will be equal to 1. But I plus 1 will become 2. And that's why we will have 2 masks. Okay. So hopefully that is clear. Now the main part is, now we have to do is finding the bounding box. So if you actually go and see the your official documentation of Mask RCNN, you will see that what you need is not only the masks, you need 3 things. You need the boxes. So if you can see over here, you need the boxes, you need the labels, and you need the masks. So now what we are doing is we are trying to get the boxes. Okay, so till here we were fine, that we have the person and then the number. So if let's say you want to find the box of this, but you only have the coordinates of this, because you know where there is a 1, where there is a 1, where there is a 0. But the problem is now you need the boxes, and the way you find the boxes is, so let's say this was the image again. You take the cornermost point. What is the leftmost point of this man? Well, the leftmost point is this. What is the topmost point? What is the topmost point? Is this red one. What is the rightmost point? The rightmost point is this. And what is the bottommost point? The bottommost point is this. So if I have to draw a box, you can see the box. I need the leftmost point, the topmost point, the rightmost point, and the bottommost point. So these are the corner points, or rather the extreme points, not the corner points. We need these extreme points, and we will be finding the corner points. And what are these points? Let's say this is x1 y1, x2 y2, x3 y3, and x4 y4. Okay, let's just assume. So what we need to make these boxes, we need this coordinate and the last here coordinate. And the way we are going to do it, or whatever we are going to call this, we are going to call this x min and y min, this top left corner. And this bottom right corner, we are going to say x max and y max. So what we need to do, we need to find these values. Only then we will be able to make the bounding box. It will be used for the FastRCNN part, that is the object detection part. So we will go to the next slide. And the way you find x min is you take the x values of all the x values, that is x1, x2, x3, and x4, and then find the minimum. You'll get the x min. So y min, how you'll get? Similar technique. You will take the y1, y2, y3 and y4, and then you'll take the minimum of all. So you will get y min. So this top left corner will be x min, y min. And same for the max. If you want to find the x max, y max, you're going to take the maximum of all the x's, so x1, x2, x3, x4. And if you want the y max, you will take the maximum of all the y1, y2, y3 and y4. Okay, so this is what is implemented over here. So position is wherever the what to say, your all the position where mask of I is equal to mask of I. So wherever there is zeros, for example, I will be 0. Okay, so wherever we are going to find masks of 0, which is here. So first person will be masks of 0, because masks was implemented over here. So masks of 0. So we will find the x min, y min, x max, y max. I showed it in the start. So all the position of 1 is all the x's, and position of 0 is all the y's. So you'll have all the positions, and finally the box will be x min, y min, x max, y max. Okay, so how this pos equal to np dot where works is, it will give you all the x coordinates in the pos 1, all the x coordinates, and then you'll have all the y coordinates in pos of 0. Finally, what you need to do is labels. Now in this example, all the labels that we are finding is 1, that is humans. We are just finding people, right? So all the labels will be 1. So that's why you see torch dot ones. So boxes, basically this was our list, and this list has been converted to a tensor using tensor dot as tensor, and then boxes over here. Labels are all 1, as you can see, and then masks are something that we had found over here. Let me go on the top. So masks was something that we found over here and defined over here, and now we are again converting it to a tensor over here. Okay, so as you can see, the data type for the mask is uint8, that is the image data type. The boxes were to be in the float 32, and labels were int64. Now target is something that we have seen, that how we have to give the data to the Mask RCNN predictor during the training time. So you need to pass a target where all of your data will be in the dictionary format. So target is a data. So target of boxes is the boxes, target of labels is the labels, and target of masks is the masks. So finally what we return the image, but before that we convert it to a tensor. So torch vision transforms as t, and then you convert it to 2 tensor, and then pass the image and also pass the target. Okay, then lastly you have how many images are there, obviously len of self dot images. Okay, now here comes the most important part of the program. So obviously the first one is you're basically importing the mask RCNN model. So this is the first line. Now what you need to do is you need to come over here. So let's say you did the same thing and you downloaded the model. This was the first line of the code. Now if you print the model, okay, now you see a pretty long model will come, but we are not interested in the whole model. We are just interested in the last part, because we are going to replace this last part. Now if you remember from the FastRCNN video, this FastRCNN predictor had to be removed and substituted by a newer one. So this is exactly what we have done. So as you can see over here, a new FastRCNN predictor has been given, which needed in features. So we got the in features from here, model.roi heads.boxpredictor.cls core.in-features, which is over here. So model is the whole model dot roi heads, as you can see over here, roi heads, and inside that you had the box predictor, and in the box predictor you had the CLS core, and inside the CLS core you had the in features. Okay, so this is how you found the in features. So box predictor, this is the thing that had to be changed. Along with that, if you see, you also have to change the mask. You also need the Mask RCNN predictor. So this is where the Mask RCNN part comes. So you have to again go and change the model, the mask predictor, which is model.roi heads.maskPredictor. So again you have to go to roi heads, model.roi heads, and then if you scroll down, you get the mask predictor. Mask predictor is Mask RCNN predictor. So this is what we have to change. So this is what we have changed. So for that you need the in feature masks, So you got the in feature masks and you needed the hidden layer, so you just initialize one hidden layer to be 256, and then 2 is over here for the number of classes. One is for background and one is for our first class and the only class, which is humans. So here also we have 0 for background and 1 is for the humans. Okay, so you run this entire cell. All this code will be available on GitHub. So and then you run this cell and then just define the transform. I don't think you need it, but whatever. And then you have a collate function. So there is already a video on this channel regarding the collate functions, but collate function is basically used to take the data and give as whatever format you want. I just returned the data, which means that I have skipped the default what to say, a stacking part. Okay, so look into the video of default collate if you don't understand. Lastly, this is basically breaking the data set into test and train. Okay, test and train and validation basically. And these are the data loaders. Okay, see, I have put the batch size 2. You can change the batch size, but don't change it in your code right away, because my further logic actually depends on this having 2. Obviously it is customizable, but you'll have to change some code. Fine. So here you have the device. Here I'm putting the model 2 device, and then this is the parameters, and then the optimizer. All these are very simple. Okay, you don't have to write params, you can write directly model.parameters. And now you see the training loop. Okay, so we will be running it for 30 epochs. Okay, so the way it is done is you take the images and then you take a list. Okay, so list, what you do, this dt. Okay, this dt is for the training data loader. Okay, so dt is, this is the images, all these images. The only thing that we have done is, since you remember we had only 2, which means there are only 2 images. So what we did is we have put all the images to the what to say, your device. And then the target, so target had 3 things. It had boxes, it had labels, and it also had your masks. Okay, so it had 3 things. So basically all of those 3 things, this logic over here, it just changes all of those 3 things to it puts all of those 3 things into the GPU. And then finally you pass it to the model, and then model.train is over here. So we are in the model.train is over here, we are in the training loop. And then you find the loss. Now obviously the loss has to be printed for the first time so that we can see what loss is actually. So that's why we had if not flag, and then you had losses equal to sum dot sum all the losses. So first I'll show you the losses. So if you see, there are certain things. There is a loss classifier, then there is the loss box regression, then you had the loss masks. So these are the 3 things. Then you had this for the RPN, so loss objectness, this is for the region proposal network. And then loss RPN box regressor, this is also for the region proposal. So this was the for the final. Okay, this was loss classifier and loss box regression, this was for the FastRCNN part. Loss mask was for the MaskRCNN part, and this too, loss objectness and loss RPN box regressor, this is for the region proposal network. Okay, so what we do, we sum all the losses. So you can see all these losses are there, tensor 0.7447, and all these losses, these numbers that you see, tensor numbers, all of this has been summed over here. As you can see, all of this has been summed, and then you have the back propagation over here. Okay, and whatever the number was, whatever the loss is, we are adding it to train epoch loss so that we can see all the epoch losses. Okay, same thing here we are doing for the validation set. So nothing difficult, different, same thing. Okay, same code, just that back propagation is not there because this is only for validation. So with that, what we are going to do is we will plot all the train losses. So once you run it for 30 epochs, I have just run it for 1 epoch over here because I had to show this, but you can run it for 30 epochs. Okay, so this all train loss has been for 30 epochs. So I changed the code and little bit run it here and there, but if you run it for 30 epochs, you can see the loss is constantly decreasing. Okay, you will have this nice graph. Your training loss is decreasing, your validation loss is also decreasing, but is making kind of a thing over here. And let's say you take an image. Okay, so let's say this was an image. I'll show it in the screen right now. The image was this one that I have downloaded. And then what you did is you pass the image, you put the model in the eval mode, and then you pass that same image, and then over here you did a transform, and then you pass the image into the model. Okay, pass the same image into the model and put it in the GPU, and then obviously the image is already shown and the prediction is shown over here. So if you take the mask of that, let me show you what the mask has been detected. So you can see the first person mask has been detected. So all this code and everything will be in the GitHub. If you have any question, do write it in the comment section. And thank you very much, and bye.